Number 6 on the 4.6 quiz on the Newton's law of cooling. So here again you have the formula. It's important that you remember that that formula has by default has the input T, that's your input, and your output is your temperature, which means usually you would be given the initial temperature of the object, you would be given the room temperature of the environment, you will be given the rate of cooling for that substance. The only thing that you will need to plug in would be T, and you'll be looking for the temperature. You will be plugging in this T here, and output would be the temperature of the object at any given moment. However, some questions might give you different information to kind of throw you off. For example, in this one, they want you to find the T, so they want you to find the input when they give you the actual output of the equation. So, however, again, when you look at this formula, you have to think about how this formula is really designed for you to put in the input T as in time and the output T as in temperature of the object at any given time. So let's go ahead and fill in the formula first. We know the rate is 0.042 and the beginning temperature is 212. So we want it to be cooled down to a temperature of 80 degrees. So let's take our T equals to T0 minus TR e to the negative RT plus TR. Okay, so let's first plug in this 212. That's the initial temperature when it stopped boiling. So that's the temperature T0, 212. The room temperature is 72 degrees. That goes in two places. And the rate is 0.042. We don't know what T is, that's what we're trying to solve. And we want the temperature at time T to be 80 degrees. Okay, so that's our formula with all the values plugged in, and we're going to try to solve for T now. The rest of this example is more about algebra than about algebra 2. So we just need to be able to isolate the variable T. So what we want to do is put T by itself by first taking away 72 on both sides, which gives you 8 equals 2, e to the negative 0.042 T. You're going to simplify this by doing 212 minus 72, which give you 140. Again, our goal is to isolate the T, so we're going to divide 140 on both sides. That cancels out. This gives us, this is 2 over divided by 4, that's 35. Let me double check. Yeah. Equals to e to the negative 0.042 T. To get rid of the e, take natural log of both sides. This is now just equal to negative 0.042 T. So my T is now equal to natural log of 2 over 35 over negative 0.042. So now I take out the calculator. I do 2 divided by 35. Take the natural log, divide this by 0.042. 0.042 negative equals to 68 minutes. That's my final answer.